Allo? Sì. We have to start because at the 8 everyone has to leave the faculty.
Il quinto che fai a 5 si addestra per vediamo un po'. Ho detto non ho sentito di dirgli di no una cosa del genere. A Roma invece di Roma e dei anni però uno che viene da fuori oggi è un disastro per lo sciopero oggi per mezzi non si traffico penso di metterci un'ora penso mezz'ora e ho fatto qua davanti volevo dire che poteva no ma io ho fatto qua davanti abbiamo io pensavo che ci fosse no quest'ora la mattina era pieno però ancora era pieno manca una sedia? Prendiamo questa come facciamo tipo come scorrere sì, fai entrare tutti in un minuto iniziamo. Vedi, quello è tuo, è giusto? No, ma infatti. Ok, ok, ci siamo. Vabbè, tanto è davanti e dietro lo schermo. No, forse sarà meglio. Possiamo chiedere. Sempre che ci sia una buona interazione sai, con le persone, no? E quello poi dopo una fai qualche domanda che vuoi dire, no, lo fai che cacchio una volta, se puoi rispondere.
Okay, I think we can start in 1 minute.
Però ma aspetta che la profilazione di persone che abbiano un po' di dimestichezza con una certa penso che meglio sì,
Okay. Okay, good evening to everybody. I think we can start, otherwise we are too late. Thank you for staying here until now. Today it was a very long day for us, but I think we can close with this very interesting panel, I hope for everybody of us, because of the topic that is one of the main new potentialities, real potentialities for the energy transition, for the decarbonization, the role of offshore wind. That is a technology quite mature, that reached some interesting steps in the northern seas, and now is opening also in the Mediterranean in the last years, mainly due to the increase of TRL in floating platforms, floating offshore wind. As you know, the Mediterranean Sea is characterized by depths that does not allow so much bottom fixed technologies, except in some cases. In Italy, we have some places in the Adriatic Sea, for example. And now it's opening the offshore, the floating ones. To give you some numbers, in Italy, we received in the last years, the Italian TSO, Terna, received more than 100 gigawatt of grid connection requests. So, of course, these are numbers that have to be compared with the real state of the art of industry, of the technology, of the main barriers, economics, not economic barriers, the bureaucracy. This is the reason why I invite here panels, list speakers coming from both academics and industrial players. I am currently the Secretary General of the Italian Wind Energy Association since the last 10 years. And I have seen also in my academic life that it's important to join, to meet, to exchange, to discuss from the academy to the companies, listen what's the voice of the industry. That is the reason why I thought that in this 4 days conference that we mainly will listen to other colleagues, other academics. It's important also in that case to have some voices from the industry. That's the reason why we have here 4 of the 6 speakers coming from a key industrial player that can give us an interesting picture of what's happening in Europe in general and what are the main challenges for this sector. I invited also 2 main academics that will give us other hints, suggestions to increase and to integrate the discussion. So another point before leaving the floor to the speakers. Also, in my experience in the last years, I was involved as expert from the European Commission for evaluating the Horizon Europe proposal about offshore wind the last years. And I have seen that this match, these synergies between industries and academics is one of the key, the winning aspect, the added value for presenting successful proposal. So that's the reason why also I am convinced that it's important here to have this opportunity for this 1 hour and a half, more or less, we have here. So I will introduce you the speakers. They will have a first round of speeches, 5 minutes more or less each, to give you a general overview. We will deeply see different aspects: batteries, power to gas, grid connection challenges, and pilot cases, as you will see. And then I will make a first round of questions, and the second round of questions will be from you, from the audience. I hope we can have some minutes to have a discussion and to between us. So I will introduce you Leopoldo Versace, that is Senior Director of Vestas. Then we have Alessandro Bianchini of University of Florence, that is also the Vice President of the European Academy of Wind Energy. We have Gbemi Oluleye from the Imperial College of London. We have Riccardo Mollo, Managing Director of Renexia. Saverio Ventrelli of Siemens Energy and also of now the Norwegian offshore wind cluster. and Andrea Santopaolo, account manager of Hitachi Energy. So we try to involve different players. So maybe we can start with Leopoldo, that will give us a first overview of the role of offshore wind for the energy transition, lesson learned, opportunities from the wind turbine manufacturer. So Riccardo, the floor is yours. I will open the presentation. Not Riccardo, sorry, Leopoldo. Where is your... Here is it. Okay, do you have the...
Or we can, yes. To change it, or this one on the right?
Yeah, I think so. Maybe, but in the PDF, I don't know if it works. I will change it for you. I don't know if with the PDF it works. It's not like the PowerPoint. Let's try.
Let's try. I don't think so, but okay. No, okay, you change it.
No, let's do it.
Okay. Good evening, all. Thank you for hosting me this evening. Thank you, Davide. I'm Leo Versace, Senior Director Investors in the business for more than 17 years in the same company, by the way. So, yeah, I think so. Can you hear me, Harold? Okay. Okay. I'm taking a role of business development and development of greenfield project in the Vestas wind system in recently new business unit created 4 years ago for developing greenfield projects and commercializing then the asset ready to build to the Vestas customer. Currently, I'm following, let's say, the EMEA LATAM region, mainly onshore development, even if we are taking some monitoring, some evolution of the offshore and the Power to X, where the most traditional part of the company, let's say the big Vestas, already did some step, especially in the apart the Power to X in the offshore, of course, which is one of the core business of the company. Just to give you some number, I don't want to bore you with who we are, what we are doing. I think the brand is very well known. We are a leading company in the wind energy with present into the market for more than 45 years. 30,000 employees we account for today, distributed in all the main markets in US, Asia Pacific, and Europe, in the manufacturing facilities, sales, service, business unit, and development unit as well. In Italy, we have a very consolidated presence with more than 1,500 people, covering, let's say, the sales and service and development and all the manufacturing facility we have in Taranto, where we added in 2023 the factory for the production of the V236 offshore machine, which is basically the bigger machine launched by Vestas a couple of years ago. In terms of service, we have, I think, the hugest fleet around the world, 57,000 wind turbine operation, only 4.3 giga in Italy. 181 is the total capacity we installed in 88 countries. 10 out of this 181 giga are related to offshore, mainly fixed bottom, say for some hundreds megawatt floating demo project that we will see later in the presentation. And of course, in Italy, we are a market leader with 5.3 giga capacity installed offshore. As I mentioned before, wind onshore and offshore remain the core business of the company. We took some first step in the Power to X. We are more in, let's say, in the learning periods. And we strongly believe that the offshore market and the offshore industry is going to take a very leading role in the energy transition. As you can imagine, we work with many customers around the world. So we are engaged in the discussion with several government bodies. And we track, let's say, on quarterly basis, the evolution and the trends and the expectation and the forecast of the markets. You see a lot of numbers in these slides, but the main note you need to take is the following. For sure, there is a high expectation and very significant growth
into the market, especially up to 2030, 2032. This is the next decade we are looking for. But the most important, let's say, observation we can take from these slides that match also with our internal market forecast, because we are used to combine all the external source with our market intel. There is and there was an important shift of the capacity initially forecast in the 2022-2026. And this shift into the future was due to a combination of many factors. First of all, many countries are resetting a bit the rule of the games. They are reforming auction. There were also PPA cancellation or abandonment in some main markets, for example, in the US or in Taiwan or in Asia Pacific too. Doesn't mean that this capacity will not be built. It's just a shifting we are monitoring into the future, where we'll see in any case, especially in Europe, markets like UK or Netherlands or Germany that we expect will dominate the industry in the next decade, while a newer market like US and Taiwan that we are following with high interest are expected to grow significantly, especially after 2027. Of course, this is just a projection, just for you to give an idea that this dynamic are changed. The situation is so fluid, and maybe in 1 year we can detect a completely different context. But what is substantial, it was a very important shift of all the capacity that many government, many developers plan for 2022, 2026. If we go on substance, we go to the next slides, just zooming in on the top 8 markets, at least what we forecast, we see the top 8 markets. The most important, the most significant downgrade on, let's say, decrease was detected in a market like US, and mainly because the high number of PPA cancellation, also about the hesitation of the government in assigning large-scale projects, or let me say also the geopolitical or political situation, the election that are creating some uncertainty also on the investor. And same, it's happening with a market like South Korea and Taiwan. They are planning a lot of volume, but again, they are reforming a bit the auction system, also because they of course, talking with customer, talking with industrial, that they have to adjust to the reality and the complexity of the offshore industry, all the offshore system, especially when looking at the floating, which is a relatively new segment of the offshore, which is, let me say, still a relatively young industry. We know that we are doing offshore bottom fix since the beginning of 90s, let me say, but we are still in the phasing of ramping up an industry which we consider relatively young. Let me say that this is a bit a collection of the outcome we are getting from developers, big players, utility, but also government in all around the world, at least in the 8 main markets I showed before. There are a lot of lessons learned coming from the markets that are showing a bit the other face of the reality. While the offshore fixed bottom is a relatively more mature industry, and most of the installation are related to the Nordics, of course, the reality for floating is it's a bit different. For sure, what we all agree is despite all this challenge that we face in terms of higher cost for raw material or increasing on impact, of course, of the storm we face post-COVID or because of the war in Ukraine, that reviewed a bit also the plan of many governments. The market is expected, in any case, to grow fourfold in the next decade, which is, of course, give us and not only us all the ambitious to play a protagonist role into the industry. But as I was explaining before, there are a lot of technical and non-technical barriers we need to manage. When we go to a floating, I mentioned before floating, we expect that the first commercial scale can be around 2030. So also in this case, especially in the floating, the timeline shift in the future. This because many markets are realizing that PPA price, for example, needs to be drastically increased. This type of industry needs to be supported. A lot of mechanisms must be put in place in order to facilitate a smooth ramp up of the industry. We see South Korea, one of the front runner or one of the potential market where we see a first utility scale in terms of floating projects, without excluding the possibility to see also in Europe. We know that France is moving also ahead, but it's just capture all the moments where we see more active, let's say, action into the ground in order to boost the transition to the floating. The rest of the trends or less of less I listed before are valid for both technology segment, either for offshore fixed bottom, either for floating. There are many factors are impacting the economies and the profitability of the projects. List have, for example, lower PPA price level that are challenging the profitability of the project. And yes, and policy framework, the well-known discussion about the maturity of the supply chain infrastructure. These are all elements that, if not properly assessed and support by also the government action, it just not easy to turn in all this plan in real project. This is the main message we are delivering. Just to end up, project timeline among the two technology sectors are completely different. Floating, as I mentioned, is much more complex. They deserve much more time for the engineering part. And this is something we are trying to explain also to the government that needs to differentiate all the supporting mechanisms to floating in a different way to the more classical bottom fixed technology. I think the time expired. So if you have any question, maybe we can.
Maybe we can open the
we can open the discussion later.
Quick first round. I should be rude because at the 8 we have to leave the faculty, so we don't have extra time here for the. So I will give now directly the floor to Alessandro Bianchini, that he can give us a first overview of key challenges in developing the next generation of floating offshore wind turbines. So thank you, Alessandro. The floor is yours. If you can give us the pointer.
Yes. Thank you. Can you hear me? Can you hear me? Right. So thank you, Davide, and thank you all for this last effort of the day. I'm following up the end of the previous presentation. I come from academia, so I will try to give you at least my perspective about the key challenges for floating offshore wind. There is a lot of discussion about floating offshore wind, so let's see what it is and which are the challenges. Is better now? Okay, so I am starting from the very big picture. So wind turbines, despite what conspiracy theories says, are a consolidated industry. They work very well all around the world. However, the scientific community a couple of years ago decided to redefine the priorities about the research in wind energy. We as scientists, we published 10 papers, which are called Grand Challenges papers. And this picture comes from the editorial, where we, the first authors of the papers, try to, let's say, to see wind energy as a pyramid. So to achieve the future of our wind energy systems, we still have to address a lot of challenges. So even though they are already functioning very well, and one of these missing pieces in the pyramid is represented by a new technology into wind turbines, which is indeed floating offshore wind. Why floating? So we have already mentioned briefly that about 80% of global new offshore wind energy potential will require foundations which are not fixed, because we need to exploit waters with depths deeper than 60 meters. However, putting the largest rotating machines on Earth, which namely are wind turbines, onto floating foundations is not a trivial task. Is not trivial because they are huge. You see in the picture that we are dealing with floating substructures with dimensions of 100 meters more. Wind turbines having hubs reaching now 150 meters in some cases. So very big machines onto floating foundations, and also because offshore wind is a harsh needs to operate in a harsh environment. So in the sea, you have the action of wind, waves, currents, and meteoclimatic events like thunderstorms and many others. So the functioning conditions are not trivial, but we really need to do that. Why the problem is complex? Because it's a multifaceted problem, starting from the design space, which is extremely vast. Just imagine that the metocean conditions a floating wind turbine will be subject to as many interdependent variables, so wind, but also waves, which need to be characterized in terms of height and peak expected period. Then you have the possible wind-wave misalignment. So the range of metocean condition that these machines will have to face is very complex. More than that, floating offshore turbines, of course, are anchored to the seabed, but they move. So the farms that have been simulated so far are fixed, but the shape of the farms in the future will not be fixed in time. So we need to be able to simulate and to account for these effects. And as said before, in the sea, the inflow is also partially unknown, because at the heights these wind turbines will reach in the sea, probably we will face turbulence characteristics which are unprecedented. So turbulence at those heights is non-Gaussian, non-stationary, non-coherent as we know, at least. And also you have, as said before, the impact of waves, wind. So the inflow conditions are very complex, but also the turbine conditions are very complex, because a wind turbine is a floating wind turbine is a complex system. Everything is extremely so the dynamics are highly coupled, because they depend contemporarily on hydro loading, the control, the type of substructure, the mooring design, and so on. Just imagine that a normal control maneuver in a floating offshore turbine will actually change the aerodynamics, then change the dynamic response, that will in turn change again the aerodynamics. And in all these aspects, there still are gaps and unknowns. Just imagine for the aerodynamics, these turbines are, as said, extremely big. Everything is coupled, as said. We have to account for wake turbine interaction. The metocean condition just mentioned before, very complex, but also the hydrodynamics, because in this case the foundations are not fixed. So the key elements is that we need actually to correctly design and simulate these machines. We need multi-physics and multi-phase methods, because there are, as we have seen, many coupled physics, and also the nightmare of each simulation guy, as I am. In the case of floating offshore wind, you need to have you need to account for different scales in your problem, spanning from hundreds of kilometers when you deal with atmospheric flows, then in the order of let's say meters of tens of meters to the turbine, and then when you go to resolve the blade flow interaction, you go in the order of millimeters or even less. So it's not a trivial task for academia. Is also why it's so challenging and nice for us. So plus, of course, as said, you have the presence of FSI and hydrodynamics. So just to conclude, there still are risks, of course. So the cost, as will be shown later on by industrial players, is high. Offshore wind has been hit a lot, as we have just seen, by the macroeconomic environment. We still have a lot to do. So industry in terms of standardization, economy of scale, the governments in terms of regulation, permitting, and so on. Academia, we have a lot of ideas, and we still, as we have seen, need to do a lot of research. Just to give you a brief overview, these are two projects. One is international, one is national. I am the coordinator of it to provide validation for floating offshore wind turbine performance. Here is a snapshot of a running LES calculation of a floating turbine. So just to tell you that, just to say that risks do exist, but in my humble opinion, opportunities, it's risk for breakfast, in the sense that we are proceeding quickly to higher technology readiness levels, but offshore wind is the only way to meet the target that Europe has posed in terms of wind power installation. So we really need to push this forward. So this close my talk.
Perfect. Thank you. I will move directly to Riccardo Mollo from Renexia, that will show us what's happening in the Sicily Channel with the Medwind project mainly.
Yeah,
the
while
experience,
you're
yes.
opening the slides, thank you, and thanks everybody for being here today at this time. I mean, I'm trying to fight tiredness through a practical example, and I will lead you very quickly through the current status of this project, which is the most ambitious one at the moment on the table. And I will just touch upon some key technology aspects, leaving everything to the following phases, where we will be asked questions from the chairman, and then you will have a chance to go into the discussion, especially, I hope, as far as the supply chain is concerned. The good news is that this one, right? Okay, so the good news is that we might be in a bit better conditions than said before by Leopoldo and Alessandro, because this project is coming along. Actually, we're targeting the first delivery of turbines at the end of 26, early 27. So we should be there in time. You will see through the challenges we faced and the problems we hopefully solved. As you can see, the setup of the plant, which is going to host 156 turbines, is 80 kilometers off the coast of Sicily. And this solves completely the problem of visual impact. You won't see it from the coast, from the shore, so there will be nobody objecting that this is kind of, say, spoiling what you can see from this marvelous piece of Italy from the coast of Sicily. Of course, this means, as Alessandro was saying before, that the water depth is it's between 500 and 800 meters. So this means that you can only make it float if you want it to be there. And clearly, also the link to the delivery of the power generated through these two lines that you see is also a challenge due to the length of these lines. However, as you will see, I mean, we tried and delved into the practical aspects of the technology. We made the turbine selection. At the moment, we actually we had started the project with a 15 meg WTG, and now we landed to a 18 megawatt WTG, whose prototype has been installed 4 days ago already, so it's already in the testing stage. The rotor will be 292. So in our environmental impact study, we actually included up to 295, so we will be within this threshold, and the tip of the blades will reach the height of a New York skyscraper. I mean, 327 meters. This will be sitting on a floater for which we have selected the Technip Energies, now called Equil technology. It is a technology they have developed already for 15 meg applications. As you see there, the length is in the range that was mentioned before, so it's slightly below 100 meters. And the weight of this thing, it will range between 4,500 to 5,000 tons. It will be clearly anchored to the bottom. In order to do that, you will see what we're doing at the moment. One of the big problems to solve here is the fact that dynamic cables exist for the inter-array systems, meaning the 66 kV. They do not exist for the export cable. The 220 dynamic cable doesn't exist at the moment, unless someone has, surprises for us in this room. So the one thing that we wanted to do in order to solve this problem and also capture another opportunity was to develop with the Acre this type of substation that will lie on the seabed instead of be floating, which will also eliminate the problem of the non-existence again of dynamic conversion and step-up type of components at this point in time. So it's coming along. We're in the feed stage. The beauty of this will be that the 66 kV connector has been tested as a wet one, so we don't need to wait for the arrival of all the turbines to connect them to the substation, whereas the 220 export cable is actually dry at the moment, so we need to install it before putting the substation on the seabed. It will be guaranteed as maintenance free for 25 years. It's a prerequisite, of course. So the last one is just to show you the team. We're together on a ship with Silaska, Seas Geosciences team. We have drilled a number of PCPTs on the place where the turbines will sit, and also along the two export lines. And we did so accurate a work that you can see on the top of the slide. We even discovered a couple of fighters from World War II, one American and one German, sitting on the seabed. At this point in time, we're actually closing our technical surveys, so we will be able also to start designing the foundations on the seabed. So that's it. And I mean, as I was saying, this is food for questions if you want, and discussions at a later stage.
Thank you.
Thank you.
Thank you, Riccardo. I move directly to Gbemi Oluleye for giving us some first consideration about how to link offshore wind and green hydrogen production. Thank you.
Thank
I'll
you.
give you the pointer.
So I'm a lecturer at the Grantham Institute for Climate Change and Environment at Imperial College London, an associate director at the Sargent Center for Process Systems Engineering, and a program director for Executing Sustainability Strategy and Green Skills for a Sustainable Future, where we support organizations, both from the public and private sector, in delivering sustainability strategies. Now, my research group at Imperial, our core expertise is developing, which is the Green Industrial Interventions Lab, is developing quantitative tools to evaluate interventions we need to reduce the economic burden that is preventing the uptake of deep decarbonization technologies within heavy sectors. And one of the deep decarbonization technologies or alternatives is green hydrogen. Now, with a lot of investments in offshore wind, both fixed bed and floating bed, you kind of need to find a sink for the electrons, and the molecule is a good sink to prevent curtailing expensive energy. So I would just go from electrons to molecules and talk about opportunities for green hydrogen industrial decarbonization, but also how to make this green hydrogen cost competitive such that we can have that supply of green hydrogen to use in heavy sectors. Now, just to give some context, so I'm going from offshore wind to electrolysis as a technology to get green hydrogen and looking at green hydrogen for use in industrial applications. And within industry, green hydrogen could be used as a heating fuel for heating or a feedstock. And this could be used in steel, chemicals, and refineries, which are all over the world. And there's a general consensus that the best place to use hydrogen is probably industry and not for domestic heating. So I'll be focusing on that thing. Now, across the board, there's a high technology readiness level, both on the offshore wind side and electrolysis side, but there's a very low commercial readiness level. Now, I'm coming from a UK perspective because from the first speaker, we saw UK was on the top of the chat for the offshore wind industry. I'm happy to be corrected, but I'll use UK data here also because I'm based in the UK. Now, the primary challenge is I've collected the data on the cost of green hydrogen from all sorts of references, and we see that there's a big gap between the price of green hydrogen, and that of natural gas. So in some sense, green hydrogen is not cost competitive for it to be used within industry. So therefore we need interventions, which is what my research does, is to evaluate these interventions. And these interventions could be internal. So it could be, for instance, using curtailed offshore wind to make green hydrogen. It could be, for instance, exploiting waste heat from electrolyzers to serve district heating networks, and the economic potential from that could reduce the price of green hydrogen and make offshore wind even more economically viable, because funding from the government will need to increase, especially if you're going to more expensive, like floating. These interventions could also be external. It could be from government policy. For industry, it could be emissions trading scheme, a business model for hydrogen, a contract for difference for them to use hydrogen. And of course, the final intervention could also be external, which is from private finance. So we've seen an increase in development of sustainability-linked bonds to support the use of green hydrogen and support the use of alternative fuels like power to X from electricity. Now, what I do in my group is to quantify these interventions and see where the gaps are and see if they're sufficient to reduce the cost and generate demand pool over time, such that we can link the offshore wind industry with the industrial sector, and they could have, a win-win relationship to prevent any curtailment of expensive offshore wind. Now, here I've just compressed my findings into a diagram. I don't have time to explain the methodology, but this just shows how these interventions can reduce the cost of green hydrogen. So internal interventions using the electrolyzer waste heat for district heating, using curtailed wind can reduce the cost. And surprisingly, you see some negative costs in the UK this year. And that's because the curtailed wind in the UK is sufficient to meet industrial demand for green hydrogen. So you're using very cheap wind. In reality, the selling price will increase because everyone wants to make a profit. But this just shows that with interventions, we can reduce the price of green hydrogen. And it seems a lot of the things we do with technology innovations and making electrolyzers more efficient, are not sufficient to get us to that tipping point where green hydrogen becomes cost competitive with blue or with natural gas. So we still need policy and private finance. Now, the last slide just shows how blended interventions can increase the commercial readiness level. Now, the TRL is not a big issue. The commercial readiness level is the biggest challenge because it's not cost competitive. So blending interventions from government, from the private sector, from technological innovations can achieve that much cost reduction. And this is for UK case study. And this, I just compared it with all the prices of natural gas available. And it's possible to have some cost competitiveness if you can leverage both public and private finance in reducing the price of green hydrogen, and also using curtailed winds to make green hydrogen, and also exploiting waste heat from electrolyzers in district heating networks. I think that's the end. Thank you.
Thank you. Thank you, Dwemi. We now move to Saverio from the hydrogen to the battery rules. How battery storage system can support a floating offshore wind.
Yes, thank you. And I will use just
before you start, to thank you yourself, Davide, and all of you listening to us. I can get the pointer. Yes. So I will go through what Siemens Energy does. I will not touch the wind turbines from Gamesa because it's already touched in the panel. I will talk about the battery energy storage and what this can do with regard to grids. Saying that before, we have to put the stage and say, what are the grids? So what are we talking about? How do you see the grids in, at least in the offshore space, the offshore wind space, into three different types? We do have the offshore grids for wind farms, as we have seen, where you can both produce hydrogen or you can produce electricity. There are some possible challenges in there, but there are also some opportunities, especially economical opportunities in that. We do have also grids that are so-called islanded grids, so not connected grids with offshore wind. Typically, it's decarbonization of oil and gas assets, or can be also decarbonization of islands that are not grid connected. And at the end, a grid can be also vessels and all the vessels that are operating around the wind farms, because this will have also a major impact and will be also a major need of that. I will guide you through with some very quick examples on those. We do see a large use also of energy storage beside the traditional grids that can be also the SVC plus the facts and so on for compensation. Why energy storage? Because the energy storage is already a developed technology, is very mature, is ready. And also because, at least for what we do see, the first wind farms, especially in the floating, will not exceed several, let's say, sizes that will, in a way, or can be so big that will require the facts or HVDC systems. So we do believe that we will go still with AC, and with AC, we do see that also batteries can be a quick fixer and can solve the majority of the problems related to those. We do have in the Siemens Energy portfolio our own battery system, as you see in the right side. It's manufactured, it's for offshore applications. It's manufactured totally in Trondheim in Norway. We do have both batteries, 100% from us, and frequency converters there. But we are also moving our steps into the, let's say, grid systems, onshore grids. For today, we do have third-party batteries. We will have now soon our own enclosure from Siemens Energy. Then we will be next step, the battery management system from us. And in, let's say, 1 year time from today, we will have also our own battery modules. So we will have a similar application also for the marine and offshore as we do have. These are some examples that we do have. How we do see the world. Typical wind farms, grid connected, as you do see there, can be floating and non-floating. You will have always a substation in the middle that can be floating or bottom fixed depending on the water depth. But it's also possible due to challenges with regard to the grids, for instance. If you do have weak grids, one way of solving this is that you will have not only let's say the substation on onshore, but it's also possible to solve potential grid problems by using battery energy storage, especially for fast frequency response and voltage control, for the dynamics of the grids, and sometimes also for weak grids that otherwise, like California, you will have a complete shutdown if you do have a weak grid and with the pendling of the wind energy that is coming in. Other applications, and you were touching just regarding the hydrogen, is this one. So it's using, let's say, solutions for pure hydrogen production, so wind farms for pure hydrogen production. We are collaborating with a company called Hyde Point in Norway, where also Kongsberg Maritime is part of. And we do provide all the grids from the wind turbines, let's say, down to the electrolyzer. This has a TRL, I do say 7 because it's not purely applied to the case, but in practice, all the sub-elements there have a TRL 9. And there the battery energy storage can stay both for levelizing the electrolyzer, but also for storing energy. And then we do have also the blue wind for the off-grid. It's a total system for decarbonization of oil and gas assets, as we have done. This is a technology that can be used already today. And finally, we do have also the ones that is used also for vessels with the DC systems that we do have for making the vessels totally electric and also with the possibility of charging at sea. So around the wind farm so that you don't have to go back and forth. Then I will open this for the next questions. Thank you.
Thank you. Thank you very much, Saverio. Last but not least, Andrea, about grid connection challenges from Hitachi Energy.
Okay. Hello, everyone. My name is Andrea Santopaolo, and first of all, I would like to thank Professor Davide Astiaso for the invitation to this panel. In the next few minutes, I will talk about what Hitachi Energy believes is the best way to address the grid connection challenges for offshore wind in the Mediterranean area. Just a brief mention of Hitachi Energy, which is still not a well-known name to most, as it officially became a company in November 2021 following ABB sales of Power Grids division to the Hitachi Group, creating a new company named Hitachi Energy. Our business is mainly focused on high-voltage electrical substation, of which we are also producer of the main equipment, power transformer, HV components, and protection and control system. Offshore wind is a well-established business for Hitachi Energy. We were among the pioneers of this sector worldwide, and today there are over 38 gigawatts of substation utilizing our products. We see great potential in the Italian offshore market, even if the Mediterranean seas present several complications. Today, I'm going to focus on the supply chain risk and the technological challenge. And let's start with the supply chain. It will be crucial for project developer to identify and plan the purchase of the main electrical equipment early on to meet the first two timelines without compromising on quality. We are not a consultancy firm. We are an electrical equipment manufacturer, but we have a business line dedicated to consulting services called Power Consulting. With this global team, we can support our partner in optimizing their electrical system design during all phases of project development. This global team has extensive experience in the offshore wind sector worldwide and could benefit from the support of local colleagues who understand the individual market specificities. We can start collaborating in any phase of the project development, but obviously the sooner we start collaborating together, the better. The results of this collaboration for us is an optimized design of the electrical system. And an optimized design for us is a design that takes up less space and therefore less weight. And we all know how important it is to reduce space and weight on an offshore platform. We strongly believe that this approach, based on early engagement that we already apply with our international partner, is the best strategy also for Mediterranean project to mitigate the supply chain risk. The other topic is the technological challenge. because remember that to date, there are no HV floating substation in operation anywhere in the world. So how are we preparing to face this technological challenge? The single line diagram of a floating substation is the same as that of a bottom fixed substation. The difference, the big difference, is that the electromechanical components installed on a floating platform will require a special design to withstand the mechanical stresses that they will endure throughout their life. This is a topic that we started addressing several years ago because we believe that floating wind will be a very important reality in the wind sector worldwide, not just in Italy. And here you can see the development status of our products for this specific application. For developing this design, we drew on our experience on bottom fixed application and floating application, such as oil and gas application, and for example, a pilot project where one of our power transformer was installed in a wind turbine with floating foundation. We then conducted a series of simulations to assess the behavior of these components at the scale required for a floating substation in an offshore wind farm. And in addition to this test, we also conducted a series of mechanical tests on significant elements of these components into our laboratories to see how they withstood various stresses. This process is the general qualification of our equipment, and it will be the starting point of the detailed design of this equipment that obviously will be project specific. Before concluding, I'd like to give a sneak peek into the design process of an offshore floating substation and its complexity. While I won't delve into every detail, it is important to note that each floating substation will be tailored to a specific site and a specific floater. This design process will require a close collaboration between the end user, the yard, and the electrical equipment manufacturer. The floater will be designed according to the specific site condition and using as input data also the main equipment footprint that we had from the general qualification that I mentioned before. Following the floater design, we proceed with the detailed design of our main equipment, and after that, all the system undergoes a series of analysis and simulation. So, in conclusion, I'd like to express my optimism because Hitachi Energy have been conducting R&D activities on products for this specific application for years. And now we are ready to tackle the challenges of the Italian seas. Thank you very much.
Thank you, Andrea. I think we can now open directly the questions from the audience because we have less than 30 minutes. So then if you have some question, we can start a debate, a discussion, or I can make some others ones. But we have here Daniele that can bring you the microphone if someone wants to ask.
It's a very generic question. I'm Nazmul from Macquarie University, Sydney. Just looking at the break-even point, what is a typical break-even point for an investment like this in terms of maybe around 15 to 20 megawatt offshore? How many years is the break-even for the initial investment?
Sorry, you said what is the break-even for? I think that there are too many factors, to put into that. It's almost an impossible question to answer because this will depend if you are talking about bottom fix, not bottom fix, about the distance from shore, So if you are at 10 kilometers or if you are at 100 kilometers, it's totally different. Depends on the wind conditions. If you are talking about strong wind like Canada or North Sea, or you are talking about Italy with moderate wind. So there are too many questions or too many variables in between, and the size of the wind turbine, of course. So yeah, very difficult to answer. I don't know if
Again, I can take something. An easy way to compare is the levelized cost of energy. If you want to compare bottom fix and floating, the forecasts say that maybe in 2030, 2032, the levelized cost of energy of the floating technology can be comparable with the bottom fix. But again, there are too many variables, which are not purely technical. There are also the seabed, there are a lot of things. How the auction are format, how the supply chain is measured. No, we need to stabilize the supply chains to scale the profitability to 2030. It's not only the wind turbine itself. There are a lot of things. It's not only the vessel, all the equipment, all the infrastructure.
Thank you. There is a question from Professor Nevenduic.
First of all, thank you very much for gathering so many, go ahead, so many experts to this meeting. My simple question is, especially about Mediterranean Sea, where the salt content is high, relatively high, do you expect any challenges from the materials selection point of view? Salty weather.
Material selection.
Materials. Thank you.
Are you specifically speaking about the turbines or in general? Well, you see, the turbine in itself clearly is a challenge, but they know how to do it. I mean, they know how to do it. And, you know, we're reading in the press that another player, which is not today with us, is facing problems, serious problems. But I mean, that's the name of the game, I would say, because this is a relatively young industry. Certainly Vestas, for instance, can boast so huge a number of applications where I don't think that anybody would actually take big chances in relying on their technology. The rest is, I mean, from a material selection viewpoint, is fairly easy. There's no specific, there are no, I would say, severe requirements as far as the floater steel is concerned. I mean, the thing that is actually now requiring attention is what our two colleagues were mentioning before them. That means adapting the bottom fixed, in particular electric and electronic equipment, to the fatigue conditions which are automatically implied by floating applications. That's, in my opinion, the next frontier, because give you an example, we've been trying to develop together with ACAR, a substation for DC applications. But there's no way that in a reasonable time frame, this AC-DC conversion equipment can be made available to our industry. This is at least what we heard. Now, if there are news, if there is news breaking news that can actually make this not a paradigm, on the contrary, say the opposite, then we would be happy. But I think the electrical and electronic equipment is what will require more attention in the coming years.
Professor Nevenduic, University of Zagreb. We did a study on potential of offshore wind on the Croatian side of Adriatic for EBRD. And we found around 50 gigawatt of technical bottom fixed and much higher floating potential, and probably around 2 gigawatt of economic potential by 35 in the northern part of Croatian side of Adriatic. The problem we encountered is Croatia is a small country with weak grid, especially on that side, and the evacuation capacity that we see is limited to maybe 500 megawatt. For anything above that, we actually need a multi-country planning to evacuate this energy. And we see that something is happening in Brussels, but not so much. So what is your view, if any one of you has an idea, are we going to have a more integrated European offshore wind policy towards the evacuation of all this wind that we see we will have relatively soon? 10 years, it's tomorrow.
Yeah, thank you for the question. I can try to answer to you. And I do understand, because if you do produce too much energy and if you can't spend it in your country, so either you have to have grids that are stiff enough first to take into account it. So meaning from the offshore coming inside. There are other possibilities. The possibilities are using some grids that we do have that they can keep in balance the grids. The batteries, as I showed to you, that is also a very quick fix for the problem. Maybe can solve both, because when you have batteries, you can store energy, and depending on the load flow between your country and also the other countries, you can make it possible that you can transfer energy without improving the grids, because what we are talking is improving the grids, and this takes ages and sometimes also agreements around. So this is something that you have to take into account. The second thing is that most probably, at least also for Italy, I've seen that the wind is not the best, It's not Greece, it's not Canada, it's not the others. My question is the wind the only solution that we do have? I'm talking it's 3 years or 4 years already. I'm talking about offshore floating solar that can be used together with the offshore floating wind to make it in a way viable, also with regard to the LCOE that we were discussing before.
Maybe to add something. This is a bit a dream, no? That the European Union, all the main countries are working, all the TSO are working on making uniform, a policy for import-export. But we are still far from there. There is a plan. And what we see in the next 15 years, probably to see all together all the, let's say, these energy systems are very well interconnected. So we don't see offshore or onshore decoupled from BESS, from battery, or from power to X. This is the plan, to have a fully intelligent, integrated energy system. Just to make an example, if we have the curiosity to look on the website of Energinet, which is the TSO of Denmark, there is a big plan to build this energy island, in the Nordic markets, and they are, let's say, designing an energy system for dispatching not only, let's say, the energy to the continents, depending on the energy demand at that moment, but also the hydrogen they want to produce and serve, of course, all of the sector. This is a big, of course, giant plan for the future. This requires a lot of investment. So far, it's Northern Europe. We don't have the same condition in Northern Europe in terms of wind, but maybe we can integrate, compensate with solar or other technology systems.
Thank you both. Other questions from the panel, from the audience?
Ingo Stadler from TH Köln in Germany. I was wondering that it seems that Italy is so focused on waiting for the floating wind turbines. And then I have seen from Ricardo this example west of Marsala, and that you go so far out that the people cannot see anymore the wind turbines. And I have the idea that The Scandinavians live very well seeing their turbines, the same in the United Kingdom and the Dutch people. But in my country and officially, obviously also in Italy, the people don't want to see the wind turbines. Can you give a bit of a discussion you have here in Italy about that issue?
Okay, yeah. I mean, the first wind farm in the Mediterranean has been commissioned by us 2 years ago. And it's a small one. It's only 10 turbines off the coast of Taranto, Apulia. And there, almost nobody complains. But the fact is that behind the turbines, you can only see the steel mill factory there. So whatever you put in between it and your visual emotions, it's going to decorate it. Other than that, I don't think that, yeah, you're right. I mean, the Italians don't like at all the idea of going to the beach and then having this thing spinning around. Personally, I don't find them ugly. But I just belong to a minority, I'm sure, because all the others are against it. So the attempt we made, which so far so good, it returned good results, was to go straight to the environmental associations, like in Italy, Legambiente, Greenpeace, WWF, Mare Vivo, and the like. And then we told them, we have a project like this one. Do you like it? Because if you like it, if you don't like it, let us know why. If you like it, we expect that you will support it, because this, in our opinion, solves all the problems. So we had a phase of negotiations with them at the beginning. Someone was saying, for instance, the vibration induced by the rotors will disturb the cetaceans. So, and then we demonstrating that this is not the case, because in Taranto, dolphins and whales are coming actually closer to the shore because there are no ships disturbing them. They told us, your blades might be killing the birds. And we demonstrated that, on the contrary, these 156 platforms will serve as a resting station for the birds that will cross the sea to go to the other side. So we took this approach, and now those agencies and associations are the best supporters we can have around promoting what we think, what we have designed. So in a nutshell, I think in Italy, I'm not sure this is going to be the same in Germany or any other place, you have to make them invisible if you want them to be welcome. That's the conclusion we came to.
And also, if I can add, the sea space planning in the Mediterranean is complex, not only for visual impact, because it's a very populated sea. So you have fisheries, you have tourism, so routes of a lot of boats going out in there. So spatial planning is particularly complex. And beyond that, the seabed is not only deep, but it's also strange in terms of morphology. So there are some sites that have been shown to be very promising in terms of wind, but the seabed is not feasible for the anchoring. So crossing all these requirements, you find like suitable areas like those in Sicily.
May I give you just one very quick story? I was 2 years ago, was in Singapore talking about offshore wind. And there was one gentleman from Vietnam, and asked to the guy if they were doing onshore, if they were going to do offshore. And he said, yes, we do already. And I said, okay, how many kilometers? It's like 50. And he said, no, 15. I said, oh, so 15 kilometers. And he said to me, no, it's 15 meters from the coast. And I said, okay, but you are almost onshore, and people does like it. And he said, yeah, because there are the young couples that are almost going to get married. That is just a spot for taking pictures with the wind turbine in the back. So I'm starting a new business, to be a photographer for the new couples there.
Thank you.
Now, in Italy, we have the problem. Before we had the NIMBY not in my backyard. Now we have not in my term of reference for the institution that wants to postpone. We have now many problems with Sardinia, for example. Other questions?
Thank you for the presentations. I have a question. The energy hubs that you mentioned earlier and hydrogen production. You can see that when you go further away from the shore, the winds are stronger and steady. But at some point, it's too expensive. The losses become too high, and the mooring, because of the depths, becomes too expensive. Do you see a future like where we can have floating wind turbines not attached to the floor, not attached to the shoreline, but floating out in the ocean, generating electricity, generating hydrogen, and then we just ship them towards the shoreline? I mean, if you look at those strips in the southern hemisphere, there are places with like 7,000 full load hours. So the levelized cost of electricity from those turbines would be really low, so we could generate cheap hydrogen. And can we even do commercial operations outside economic exclusive zones? Can we do stuff in international waters like that? Thank you.
I'll start the answer and leave it for the experts to finish it. We've started doing some feasibility studies to see if it's possible to co-locate hydrogen production electrolyzers with offshore wind, because it may be, cost effective to generate hydrogen there and transport it. But transport and storage of hydrogen is another big issue. So you really want to focus on a distributed way to use hydrogen, but I don't have the final solution on which is better, whether to produce hydrogen closer to the end user or to produce closer to where the renewable energy is, offshore wind, and then transport to the end user. I can't say, but there are studies to evaluate the impact of both.
Yeah, we have been looking to what is called decentralized, so having electrolyzers around the wind turbines or integrated with the wind turbine, or a centralized system. It seems that for now, that maybe it can change, and surely there will be space for both. The centralized solution is the ones that works better. But apart from that, I do believe that when you are a certain distance, as you said, with the distance and the cables and the cost of the cables and so on, the best will be to produce locally hydrogen. And instead of sending cables and then transforming energy, because you have 28% losses more or less, then you should produce directly molecules and send these through pipes. And you need a 10-inch pipe, because if you compress at 190 bars or whatever, that is not a big deal, then you can send just the hydrogen through it, and then you can use it onshore for the industry.
I have a small short question for Andrea about the status of HVDC substation development. To close the...
Okay, perfect. Thank you for the question, Davide. Yes, of course, HVDC in offshore substation, it has become a reality in the North Sea. And we have accumulated a lot of experience in the last 20 years with HVDC offshore substation for bottom fixed wind application. Regarding floating solution, at the moment, R&D activities are ongoing, but please consider that most of the components of an HVDC substation are the same of an AC substation. So part of the job is already done. But anyway, frankly speaking, we do not see HVDC as a solution for the Italian project that aim to be connected within 2030, because it's too close. But as far as we understood, also the cable manufacturer share our same vision. We are ready. We are sure that HVDC for offshore wind in Italy will come into play in the future for larger projects, but at the moment, it's still a HVDC in Italy, it's still a solution aimed for other applications such as international link. You have also to consider that at the moment, HVDC is a mandatory choice when you need to connect the power above 1 gigawatt with a distance longer than 100 kilometers. If we are below these thresholds, for sure, AC is still the best option at the moment.
Thank you, Andrea. Maybe we have 2 minutes for the last question. Then we have to go out quickly because otherwise we will have to sleep here.
Very quick question. There have been some concerns expressed about recycling the blades of the turbines. And then I've seen some announcements that this has been on the way to be solved. Now, what is your information?
I think is no, I think is also a mandatory requirements under the permitting policy of the European Union. So it's an obligation. This is something we are addressing as a manufacturer developer in the environmental impact assessment in a sustainability program. There are many ideas how to recycling blades, material for blades, or the destination use about these blades. Of course, we need to see case by case. There is a product program launched not only investors, all the main manufacturer already investing resource and money how to tackle the topic, knowing that is part of all the Western policy. We can discuss separately if you want. There is a dedicated group working on blades recycling in investors. So, and not all investors, also same for Siemens. That's a complicated chemical problem, but is manageable because mostly you can recover all the materials. Of course, we also trying to drive the decarbonization in avoid any using of components coming from the fossil or oil gas industry. That is the plan of decarbonizing everything. But yes, there are still issues we need to manage and address internally.
I can just support. Yeah, I can just support what you said. Vestas and the Siemens Gamesa, Siemens Energy. By the way, they are just one beside the other in Denmark. If you go to Vejle, you don't see the difference almost. Yeah, you can change one to the other, but they are doing very good steps in there. It was announced at the ONS in Norway, in Stavanger, 10 days ago. We won also the Innovation Award for recycling blades. I think that you are there or two. So this is the European industry that is there. Mostly if you compare to the Chinese, that is the other one that is.
No, we are not acting as a standalone. We are speaking with the Siemens, with Nordex, with all the other players.
Okay, thank you everybody for this beautiful discussion, and we will see tomorrow morning. Thank you to all the speakers that accepted kindly our invitation. Have a good evening, everybody. See you tomorrow.